Hi guys, welcome back to Enginerds YouTube channel. My name is Patricia Bermudez and I'll be your host for today's video. And for today's video, we will be continuing on open systems, but for this problem, we will be focusing on pipes. So the problem states that air enters a pipe at 50 degrees Celsius and 200 kilopascals and leaves at 40 degrees Celsius and 150 kilopascals. It is estimated that heat is lost from the pipe in the amount of 3.3 kilojoules per kilogram of air flowing in the pipe. The diameter ratio for the pipe is d1 over d2 is equals to 1.8. Using constant specific heats for air, determine the inlet and exit velocities of the air. So for this problem, we're gonna use two equations, two unknowns. Kasi yung V2 natin, which is the one at the exit, minus V1, is both unknown. They're both unknown. So we have to use both the open system energy balance and then the continuity equation to find the velocities simultaneously. Okay, so we have a pipe here, like so. And then there's air that flows in and there's air that exits. So the condition of the air that enters is that pressure is equals to 200 kilopascals. And then the temperature is 50 degrees Celsius. And then at the outlet, the pressure is 150 kilopascals. And then the temperature is 40 degrees Celsius. Okay. And there is heat here that is equivalent to negative kasi heat is lost. So negative 3.3 kilojoules per kilogram of air. Okay. And then there is a ratio. Let's say D1 is equivalent to 1.8. And then D2 is equals to 1. That's why when you put D1 over D2, it is still equal to 1.8 over 1, which is 1.8. Okay. And then we have to find V1 here and then V2 here. They're both unknown. So this one is P1 and this one is T1. And then here's P2 and then T2. So using open system, energy balance, we know that Q plus work is equals to the change in kinetic energy plus the change in potential energy plus the change in enthalpy. But then for pipes, we know that just like nozzles and diffusers, they produce no work. So the work here is equal to 0. So we can cancel this off. And since in the problem, there is no change in height given, we can assume that the change in potential energy is 0 as well. So we're left with Q is equals to the change in kinetic energy plus the change in enthalpy. So you have Q is equals to the change in KE plus the change in enthalpy. And then we know that Q is negative 3.3 kilojoules per kilogram. And then the change in kinetic energy is V2 squared minus V1 squared over 2 GC. But then for SI units, or GC is equals to 1 kilogram meter per second squared Newton. And we know that Newton is equals to kilogram meter per second squared as well. So this whole thing will get cancelled off. This one will get cancelled off. Kasi this one is equivalent to this, so it'll just be cancelled off. And since GC is just equivalent to 1, let's cancel this off because it's just equivalent to 1. And then for delta H, we're going to use the specific heat of air. Okay? And we have to assume that air is ideal and diatomic. So ang CP natin is 7 over 2 and we use 8.314 as our R, and the unit for that is joules per mole Kelvin. And then we have to multiply it by the change in temperature, which is 40 minus 50. 40 minus 50, and this is in Kelvin because the change in temperature in Celsius is the change in temperature in Kelvin. And you can see that Kelvin will get canceled off, and the unit that will remain is joules per mole. But we know that our unit for velocity is meters per second, right? And since it is squared, it'll be equivalent to meter squared per second squared. And we know that joules per kilogram is equal to meter squared per second squared because joules is equal to Newton meter and then per kilogram. Then we can simplify it further to become kilogram meter and then another meter here, so it'll be squared over kilogram and then second squared kasi kilogram meters per second squared yung newtons natin. And you can see na makakancel yung kilogram here. And what is left? Meter squared per second squared. So joules per kilogram is indeed equal to meter squared per second squared. So we can simplify this here as this, okay? This one, we have to multiply it with the molecular weight so that this mole will be replaced with per kilogram, okay? So for 1 mole of air, there is 28.96 grams. And since we're talking about the SI unit for mass, which is kilogram, we have to convert grams to kg. So we have 1,000 grams is equivalent to 1 kg. And you can see here that the mole will get cancelled off, and so will the gram. And what will remain? Joules per kilogram. And then here it'll be meter squared per second squared, which is equivalent to joules per kilogram here. And therefore, the right-hand side is consistent already. But how about the left-hand side? Joules per kilogram. We have to convert kilojoules into joules. We have negative 3.3 kilojoules per kilogram. And then we multiply this with a conversion factor. We know that 1 kilojoules is equal to 1,000 joules. And then it is equivalent to V2 squared minus V1 squared over 2 plus 7 over 2 times 8.314. And what will remain joules? And then we have 40 minus 50. And then we have 1 over 28.96. And then we have 1,000 over 1 kg. Okay? And you can see that this will get cancelled off, joules per kilogram. And this one is meter squared per second squared, which is equals to joules per kilogram. And then this one is in joules per kilogram. So they are, this whole thing is dimensionally homogeneous. So we can equate this. But since there is two unknown, there's V1 and V2, we have to use another equation. So here, we're going to use the continuity equation. And we know that the mass flow rate at the entrance here is equal to the mass flow rate at the exit. And mass flow rate is equivalent to V times the cross-sectional area times density. And we know that density is equals to P times the molecular weight over RT, like so. And then we can replace this whole thing here. So we know that V1, A1, and then P1 times the molecular weight over R, P1 is equivalent to V2, A2, P2 times the molecular weight over R, and then T2. But since molecular weight and R are constants, we can cancel it off. Kasi yung value naman on the one side is equivalent to the value on the other side. It doesn't vary because the molecular weight of the air is consistent at the entrance and at the exit. Okay, what we're gonna do is we're gonna translate this A2 to become diameter. So we know that area, yung cross-sectional area, A, it is equivalent to pi r squared, because it is the area of the circle here. But then what we have is diameter. So we have to use r is equals to d over 2. So simplifying, we have pi times d over 2 and then squared. And then we distribute this squared to d and then over 2. So it will be simplified to become pi over 4 d squared. So therefore, this equation becomes v1 and then pi over 4 and then d1 squared, p1 and then over p1 is equal to v2 pi over 4 and then p2 squared, and then we have p2 over p2. And since pi over 4 is yet another constant, it will get cancelled off. So what will remain? We have v1 d1 squared p1 over t1 is equal to v2 d2 squared p2 over t2. And since ang ano natin are v1 and v2, we have to make either one of them the subject of the equation. So I'm just going to choose v1, okay? So v1 is equivalent to v2 d2 squared p2 and then times t1, kasi this one will get transposed. This one will get transposed here, and then this one will get transposed here. Everything will get transposed here. So over, we have v1 d1 squared t1 and then yung t2. Actually, since nilipat natin siya dito, tapos ito naman din lahat ay lilipat sa denominator on the right-hand side, then mariretain lang siya actually. Actually, I made a mistake. v1 shouldn't be here anymore because na-retain nga siya. Okay? And simplifying, we have v1 is equal to v2 times d2 over d1 squared times p2 t1 over p1 t2. And we know that d1 over d2 is equal to 1.8. But since this one is the reciprocal of this, we have to take the reciprocal of this as well. Okay, so d2 over d1 will become 1 over 1.8. Okay, so substituting, we have v1 is equal to v2 times 1 over 1.8, and then this one is squared, times yung P2 natin is 150 kilopascal, and then yung T1 natin ay 50 plus 273.15 because we have to convert it into Kelvin over 200 kilopascal times 40 plus again 273.15 Kelvin kasi we can take the ratios of temperatures that are not absolute. Okay? So, makikita natin makakancel yung kilopascal, makakancel yung Kelvin, and this one is unitless. So, kung ano yung unit ng V1 will be the unit for V2, and that will be in meters per second. Okay? So, in terms of V2, our V1 is, we just have to calculate for this. And then that will be our coefficient for V2. Okay? And our answer is V1 is equivalent to 0.23887335. V2. Now we have found, so this is your first equation. So this is your equation 1. And then this is your equation 2. So now what we have to do is sub equation 1. Oh, wait, no, sorry. Sub equation 2 into equation 1. Then you substitute what we have found here in this variable here, and then we just copy paste the rest. Okay, so ang value natin will become negative 3.3 times 1,000, and then our unit for that is joules per kilogram, is equivalent to V2 minus yung V1 natin in terms of V2 is 0.23887. We just take the 5 decimal places here. So it'll be 0.23887 V2. And then this whole thing is squared over 2. And then you plus this whole thing. Let's just calculate this, the right-hand side, okay? And it'll be equal to 7 over 2 times 8.314 times negative 10 times 1 over 28.96 times 1,000. And the value for that is negative 10,047.99724. Okay? And then will be negative 10,047.99724. And that'll be in joules per kilogram. So, shift solve. Our value for V2 is, oh, I forgot the square. You have to put the square here. 119.6355245 meters per second. So we have found our exit velocity. And now for the entrance, we just have to use this equation. We have to use equation 2. And then from equation 2, you know that V1 is equals to 0.23887 V2, which is equal to 0.23887 times 119.6355245 meters per second. So V1 natin is equal to 28.57733,773 meters per second. And that is our entrance velocity. And that is our solution for the problem. I hope you learned a lot from today's video. Thank you for listening and stay tuned for the next one. Bye-bye.